Welcome back, guys. Another week. So, where did we leave last week? We left off somewhere here. Yeah, so we were able to pass the DTD, and then we were going to some debugging regarding this stupid error that is to allocate something inside the linker script and use it properly within the, well, I mean, like, at least you need to declare it properly I would say initialize it properly. Where have I done it? It doesn't seem to be there. It's here. You need to initialize it as an array, so it will properly take the address, and we can then just send it back. And what else? Now we can just think about how to use this array map, whatever that we have allocated, because as you can see, we have a bitmap now and we can use it right now. So let's go back and think about why we need it, because we have an bitmap that is of size of the page tables into 8 bits, because every bit is a page, so we can keep track of all the pages that are currently being used. So when we'll be writing a helper, and if that helper, anyone can call that helper, most probably it's going to be called by kloc, because it's the kernel level. Kloc probably is called like mmap. So it's going to someone has to keep track of the physical pages that are currently used, and this is going to be that helper, and it's going to keep track of no matter who wants new pages, they have to go through this, and this helper is just going to simply set a bit. I guess I've explained how it might work previously, but let's just go through it. Let's say the entire bitmap is currently, there's nothing there. So if someone wants, let's say, allocate so they have asked for this, and let's say they asked for 200 MB, or they asked for 200 bytes. We can only give out space that is 4 KB aligned, because that's our page table size, that's our page size, not page table size. So if they want 200, we need to first okay, let's maybe I guess we need to allocate to one page should be enough for 200 bytes. So what do? We just go through the bitmap. We maybe write a for loop, and we go through the bitmap and see which are the bits that are currently being used, and choose the next bit that's currently not used. That's it. The algorithm is super simple. We just find a bit that's not used. Nothing much. Maybe we could even write a simple data structure around it, like, let's say, struct allocated, and we can have it like it will internally hold a bitmap. So it will be and star bitmap, and it will also hold the last used index. So it will have an index, usize index. Now it will be even more simple. It'll probably like an let's do it as u into 64 then. It's probably like a z o of 1 operation, because will always have the last index, so we can just index plus 1 and take that bit. Nothing much. It would be super simple. Let's write that function directly. At least write a gist of what we might be trying out. One thing we could do is that we could try out this in a separate session, and that way we will actually will be able to try this out. Let's do that, and we could finally just copy paste everything here. Let's just create a test.c. We'll just do it here inside that. Okay. I guess it's in desktop, host kernel tab, kernel simple MMU. Okay, now we can go into core. I guess it's source, I don't know, it's core, and we already have the type. We'll just open that file and we can do things here and test out the setup, so we can will have an idea of what we are working with. Wait. For me it's Control B and lower. Okay, just press down button. But in Mac OS it's fucking with me. So I press this, and should I press this? No, it doesn't work. Should I press this? No, it doesn't work. If I press this, it's going somewhere fucking else. I think it's not fucking doable in this fucking Vim, or at least in macOS. No, I have done it. I don't remember how exactly, because my daily device is a Linux, so switching between macOS and the Linux is just too fucking, yeah, but doesn't matter. If we can just type, it should be fine. We need stdio, and then what do we need? We also need I guess we don't need much other than nothing much. Maybe we can have std types. I guess it's std, it's std def, no, std int, standard int. I guess these two things are enough. And then we can start with the main. It's not gonna take anything. Why is my, I guess, set tab stop for what? Oh, I have to type it like that. Set tab set tab stop equal to 4. That should do. And we can type what we need. Let's just go to the top first of all and create the struct. We need a struct allocate mem. Let's say, yep, that's what we need. And we can and it will take a char. No, let's just put uint 820 star buffer, and we also need index, current index, uint 64 underscore t index. What else do we need? And we have this. Now we can, let's just assign it here. We can't create a linker script for this, that would be too much. We'll just assign it as a static buff char star uint 8 star buff, and the size would be let's just choose some every bit, so we only need 128 KB of memory. So I think let's try. We need 128 KB. 1 KB is 1000 bytes, I guess. So I guess we'll just type this here. 128 KB into bytes. It's super annoying. What the fuck is here? What's this? Let's just fucking close this. How the fuck am I supposed to bring it down? There is no... Okay, should be better. So we just yeah, let's just try divided by 8. I think so. Let's just put 16384. Now let's just allocate the main memory. So of R it would be like struct main allocate mem mean equal to we can allocate it in stack, it's fine, or we could do the what the fuck. Hopefully the screen is still staring. Okay, I pressed the switch off button for some reason. Main dot buffer equal to buff. It's already int star, so you just put buff main dot index equal to 0, because 0th is the last index. No, last index should be null. But how do we define null? There's no optional in. Yeah, let's just put null. I think it should not. If we put 0, we also might want to use the 0th index. Yeah, then let's just decide that we'll never use the 0th index. Okay. Now what we can do is we should be able to write and help a function that is going to give a void star mem equal to what we have to do. Actually, this function is not supposed to give out a memory. It's just going to allocate the its internal bitmap saying that this particular page is used, and it has to actually go into the page tables and create a page table entry for that. Only then it will be valid. Or probably we have. So we need a page table entry, and we also need yes, that will be fine. So this does not have to return anything. This just has to return whether we succeeded or not. Let's say it's std bool this only has to return bool success allocated. Let's say it's allocated, and we have a function that will be allocate mem, and it's going to take first parameter as allocate mem, and the second parameter would be How many page tables do you fucking want? So how do we calculate how many pages do we want? It will be like the memory divided by 4 KB, because a single page 4 KB page 4 KB page in no, we can just say 4 KB in bytes. This is how much a single page table can hold. So we can hold 496 bytes. So so it depends upon how much they want. If they want like 200 bytes, just one page is enough. So how do we do this calculation? We can divide it by, yes, I guess we could just input divided by, if the input is it would be like let's say they're just going to give a size here. Let's say they give 200. And we go here. And we create the function. How do we create a function in C? We write function. I fucking forgot how to write a function. I guess it's just bool, and the function definition, that would be allocate mem, and then we can take the input as allocate what? Okay, allocate mem. Should we take a pointer? It's a stack variable, so I think we should take a pointer to it. So yeah, allocate mem and the size, total size, that is uint 64 size. And then we could just type the okay, what do we have here? This will be our function definition. If we reach the end, we say it's false. If we don't reach the end, holy fucking moly. Holy moly. Oh, okay. Now what do we do? We need to check if it is less than, if the size is less than 4096, I guess, for equal to, probably we will consider it. We could just return if it's, we only need to return one page. return set bitmap mem1, because we only need one page, because no matter how big it is, we can only give them in pages. So if it's less than that, we just give it as one. But if it's greater than that, then we can divide it. We need to divide it. How do we divide that? If we divide it by 4096, and if the value is just some 1.5, then how do we decide it? Yeah, we can just take the numerator plus 1, because numerator plus 1 should always work. Because if we are in between, let's say 1.5, 1.6, or 1.1, 1.2, still it doesn't matter. Will have to allocate two pages. If it's like 6.5, we'll still have to allocate 7 pages. So I think it should work. But how do we get the numerator? I think we just divide. If we give percentage, then it's reminder. Let's check it. Let's check the fucking thing. Let's try for 100 divided by 4096. It's 1 point something. But Python is able to give it as extra after float value, because we don't need that. We'll just but if we use percentage, I guess it will give what will it give you? Why is it 4? Yes, the difference. Reminder is 4. Yes, that's correct. Yes. Then we could just divide it by. So we'll put as u in 64. U in 64 underscore t val equal to u size divided by 4096. I don't know if I'm doing it correct, but I hope so. I think it's correct. We can now now we have the thing. We can just put val equal to val plus 1 because we know that. But what if the size is exactly a divisor of 4096? That's also simple. We could just take u in 64 t rim equal to size percentage 4096, and we can put like if val greater than 0 and rem equal to rem also greater than 0, then we know that val equal to val plus equal to 1. There's another condition that would be if val is greater than 0 and reminder is equal to 0. We don't even have to care about that case. That case is just well, we don't have to care about that case. Yeah, and then we could finally call the set bitmap mem and val. Looks good, looks good, looks good. I really want to change this fucking size, but I'm not able to do it for some reason, because hotkey is Control B and maybe wait, do I have that tmux conf? Yes, I have it. Oh, why the fuck it is not working? Holy fucking moly. Maybe I have to do it like this. What the freaking crap? Wait. Okay. Rename window is working. Move window is also working. So if I try this, that's working. But only resize is not working. Interesting. Oh, fuck it. We can't even use... Oh, we can use our mouse to move it. Oh, I did not know that. Okay, whatever. Well, now we have now we have a setup. So we have the allocate memory that will have a buffer and the index. We have the actual allocate that's just going to take a size, and because our page table size is 4096, if it's less than 4096 we just have to give them one page, so we set 1 bit. If it's greater than 4096, then we have to calculate how many pages do they actually need. So we think about it in terms of two ways. That is, one, we just divide it by 4096 to get the numerator, and we get the reminder. If there's no reminder and if the value is greater than 0, then we know that we can just give them val plus 1, that is the numerator, plus 1. And then we can also, if there's nothing else, we can just set the memory with the number of value that we have calculated. Now it's time to write the bitmap, and the bitmap is also supposed to be an okay. Let's return it. Return. Now let's do the final implementation. That would be set bitmap. That's going to take I guess it's going to take the same thing, so we can copy it and paste it here. And if we go to the end and and where's my I hate this fucking thing. Always have to change this. Now we just go to the particular bit and we fix it. Okay, how do we go to the particular bit? Because this is a uint8 buffer, so every index can have 8 bits. Is it 8 bits? I think so, it's 8 bits. If it can have 8 bits, then I need to use shift operation to go to that particular bit and set it. Yeah, first of all, we need to go to the particular index. So how do we calculate index? Uint 64t current index. We have two things. We need to find the index and then we need to find the bit within that index. Current index would be not the index value that is set here. I think, do we even need this bit? Yes, we need it. If we have this index, then technically we just have to set the next 8 bits from this index, right? Let's say we are in the index 17 and there is 3 bits set within that index. What we have to do is, and if we want to set 3 more bits, we have to set the 18th, 19th and 20th bit and update the index value to if we have reached beyond that value, we have to update the index. If not, we just keep it as it is. Okay, then let's just keep index and a bit value. Uint8 current bit. Bit equal to 0. Zeroth index and 0th bit. And now we need to increment the bit. This fucking logic is going to be interesting. So first of all, I need to know how many index does 8-bit value can have. let's play around and find it out. Is it bin? Yes, it's bin. So let's try 8 and so that's there's how many bits in an index? That's the question. We have the first index, and that index is 8 bits, int 8. So that is like int of 0 0x 2 3 4 1 2 3 4. So this is what we will be having. So it's a 8-bit value, and if the current index is 1 and the bit is 0 1 2 3 4 5 6 7, so there's 7 bits. What happens if we have to free a memory? I think this logic won't work. I mean, like it in paper, if we are just keep on incrementing, it will work. But what if we want to free some pages and that is in a previous bit? What happens to that? Yeah, what would happen? I think I'm fucking with it. It's not the way to do it. I mean, it is a possible solution, but I don't think it's correct, because let's say I do it this way. I just keep track of the index, and every index I just keep incrementing the bits. It will work, because every time we want to allocate something, we are just going to give it a new size, and it's going to increment the index. That's fine. But what if, I mean, like it's just a valid case, we will want to remove pages, because when a program is over, it's going to say that I have finished with it and let's free these pages. So let's say we are in the current index of 17 and we want to free a page that is in third index. What do we do? We could go there and we could just hmm no, 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 no. That's interesting. Now I'm fucking confused actually. So maybe we'll have to write it down to understand it better. Let's see. What do we have? We have a case. We have a case where we'll want to allocate new memory. So we say we want the 15th bit. Why do we exactly want the 15th bit? Actually, that's now I'm completely clueless, because we have allocator. This allocator is not a high level allocator that is going to do some extra stuff. This allocator is only job is to track the physical memory. So we need to know whether a physical memory is allocated or not, and we allocate certain pages, and we might also want to deallocate that certain page after the allocation. So now the issue will be the deallocation, because how exactly do I deallocate it? So let's say it says, let's the user program says that I don't want this particular memory. How do I reach, how do I come back to that particular memory and release it? And how exactly will I use that newly released memory? So there's two questions. One is, how am I gonna remove index, and how exactly I'm gonna use that removed index after that. So there's two questions that needs to be answered. So far there's only one question that I have a small answer, that is just how we can allocate new memory. I mean, allocate new pages. That's just some. Well, my solution is to keep track of the index and keep incrementing it to get new pages. But that algorithm is that won't work. So I have to, whenever I go in and I try to allocate something, I have to start from the beginning so that I don't miss any empty patches. If there is an empty patch, I should be able to allocate it. Okay, let's just see some basic algorithms for this. Let's see. I have a bitmap for keeping track of all physical pages that are currently used. What are well-known algorithms they use to find the new page within this bitmap and also release it when needed. Let's start with this. Classic allocation algorithms and classic free algorithms optimizations. Okay, let's see. We have 4 KB pages, so there's 4096 bytes. That's a common page size. So the physical memory is divided into n pages, so we'll set 1 bit per page. That was our idea. So if a bit is set, we know that that page is used, and if the bit is not set, we know that that's exactly how we designed this. We have a buffer and we have an index, and within every index we have bits. If a bit is set, we know that, and that was our key idea. So whenever we want to allocate new memory, we just set a bit in that memory, and if the memory is in some index, we just set the next bit within that index. That was our idea. But the issue is that, what if we have to free the memory? Because if we free an index that is behind our current index, we'll never be able to use this in this strategy. So this, I don't think this is anything, this is valid at all. So let's try naive first bit, linear scan. So scan the so this is like the naive approach. We are just going to simply scan everything. We start from the beginning and we look for let's say we want 4 free bits. Then we start from 0, we keep going. Whenever we see a free bit, we keep checking if there is enough free bits If there is enough free bits, we set it and we go back. If not, we just keep looking. See, this is how it is. We get the bit and we set the bit. This is fine, but we won't have what's that, contiguous memory, because we need something that is one after the other, so it will be faster and we don't have to do a lot of switching. But if we start the search from there, what if there is a previous bit that is free? That'll be never be used, because even here I was trying to do the same thing. I thought maybe if we can keep track of the index, we don't have to do the entire search. First free word scan. Instead of scanning bit by bit, scan one unit at a time. Skip words that are. Here we are only able to set one. We are only trying to get one page. And this is like the one that is used in real kernels, the body allocator. Leave that. I have another question, that is how exactly handle the case where I need multiple pages. Then I can't just go through this map linearly, because no, I can actually, because that's the whole point of this that's the whole point of this physical memory thing. Because let's say we are giving the user a virtual memory of some contiguous block that's next to each other. The same thing doesn't have to be equal in the physical side. In the physical side, you just find the next bit and you can map the virtual memory to physical memory. Yes, I think that's so. In case where we need multiple pages, so in case we have we need multiple pages, the virtual memory will be continuous block, but in physical we can map them to the next free bit that we find. Is that how it works? Because when we free things, there will be patches of physical memory and they can be still used properly. So virtual memory is always contiguous because the user or the kernel, they have a virtual memory address space. So for them, there's no patch. They could easily find a bit of continuous memory. But for the physical, does not need to be contiguous. We can just map it like this. Yeah, this is what I wanted to say. You have a virtual memory that is, let's say, 011. We can map this to the next page that we find, and we have a virtual memory 2000 when we can map it to the next page that we find, and we find this. So it doesn't matter, we could just map it to anything. Yes. And what do we do when we free it? When we free it, we have to actually go into the page table and we have to find the physical memory and set it to free. Okay, so there are cases where the hardware devices might need continuous physical memory. In that case, we need to find k consecutive bits, but that's not in our use case. In our use case, we are just going to use this kind of method. This is what we are going to be doing. Okay, so let's keep thinking about it, because now we need to do one more thing. That is we need to write an helper function that's going to find the next free bit. Yes, and within this bitmap, we're just going to iterate to the size, and we are going to find the next free bits, and we are going to allocate it. Okay, let's say we do this. We also have to do one more thing, that is do the actual mapping. Because in this, only at this point we know, we have to know the virtual memory and the physical memory, and they need to be mapped. Okay. I get it. I get the point. Let's see if we can make it walk. Walk. Let's see. What we do. What do we have here? It's simple. What we have to do is, I don't think we'll be having index. I think we are going to I think we are going to leave these two stuff, because I don't think it's needed. Let's remove those two stuff. In that case, I don't even need to do this extra struct. I could just use this, because that's what we are going to do in here too. Let's first of all write the initial solution and then think about optimizing it, because we should never try to optimize things before writing a small version, because you'll never know what to optimize. Let's see. uint 64t I equals 0, I less than size plus I. Now we are here. Now what do we have to do? We have to call allocate bit. No, find free. Find free is going to give us the index. No, find free is just going to give us an index and a bit. So it has to give us two things. How exactly it's gonna give us two things? There's no tuple. We'll just allocate that. Struct bit index. We'll give it as something, and it will have uint 64t index and uint 64 no uint 8 bit. So these are the two values. That's so it's going to return a bit index. Let's put type def then. Type def struct the index. Okay, that should do, and it is going to return us a bit index. And if it returns a bit index, all we have to do is just go into mem bit index of no mem dot buffer. It's buffer, right? Yeah, it's buffer. Within that we need to go val dot index, and we shift and val dot index value, we need to set the bit. It's simple. Well, let's just save uint 8t temp equal to this. I think I'm not doing something, but let's see. Temp equal to temp, and we have to left shift 1 inside temp we have to set the bit. So if it's 4th bit, I got it. Maybe this is not the best way, but at least it will work. We get 1 and we shift this 1 to val dot bits. I guess it's val dot bit. Now we can just say this is just val equal to p equal to, and we can say temp equal to mem buffer val. What the fuck? Okay. Val dot index equal to temp r v. Here we'll be setting the actual bit. We'll set the bit to 1. Here we'll r it to r it in the sense r it, and that should be enough. We just keep doing that. Yes. It should work. It should fucking work. I believe it should work. If not, we'll just finally try to debug what's going wrong. I think it should work. Now we can write the final function that will return a bit index. And it's find free. It's not going to take any inputs because I think it should take an input. Input will be the mem. And let's type allocate star mem. Okay. Now what we have to do? We just keep going. We will have to it is actually a uint. We can convert it into a char buffer and we can just keep going. Oh no. It's fine because we also need the index bit, so it's fine. We'll type uint 64t index equal to 0. We'll always start from the 0th index and we'll increment the t value will be the bit. That will also always start from 0. We'll go infinitely. This is not correct because we should stop at, let's say, index is we should stop if index is equal to if index is equal to what, 16384 16385, then we stop. Other than that, we just keep going. This is a funny for loop. I have never seen this fucking for loop. We don't have an initialization. We only have a final case, and we don't have to do any incrementing because we'll be doing it internally. And let's see. Now, now we just have to do what? We have the index, we have the bit. We just keep incrementing it. That's it. We have to check the current index, current bits. I guess we need to do this operation. Maybe if we put this operation into a function, it'll be even more faster. Check if a bit index is free or not. So it only has to give us bool check free, and it is also going to take allocate. I think I have missed the actual sentence. Holy fucking moly. Now we have to rewrite the same statement. That we can yank it. We can yank the next 4 values. I don't know why I yanked the next 5 values. I didn't tell it to yank the next 5 values, but it did it. So we'll live with it. We can just remove the 5th value. And we can also do one more thing, that is just bring this. Why do I, if I keep tab, why does it go 4? It's so fucking annoying. What? This fucking thing is so much annoying. Okay, I think this is what we have to do. What we have to do is check index will also take the current index and bit, I guess. uint 64t index and uint 8t bits. Oh fuck me. Sometimes I don't understand why it does what it does. And we can index, and we can also remove this, and we can also this only has to check it. Setting the bit is done here. Okay, so we don't need this step. Yep. This is AND operation, because if this bit is set, we'll get 1, if not we'll get 0. Hmm. Return true. Return false. That's it. So what do? We take the current index, we create a temporary value 1, we push it to that bit. So this particular value has that particular bit set. Now we take this temp value and add it with this bit. If they both have the same bit set to 1, we can set it to true. Actually we are checking if it's free or not, so we actually have to set return false here and return true here. What the fuck? Okay. Hopefully we are not over engineering it. We are not over engineering it. Okay. That's fine. Now we check if check free of mem and index and bit. If it is free, then what do? If it's free, we can return the index. We don't have to do anything. Bit index. Can we do it like this? I don't know. I think we can. I don't know. Maybe I'm confusing Rust with this. If it is not free, we just increment the bit plus equal to 1, and if the bit we have some edge cases, because if the bit is 8, we have to increment the index. If we have reached the 8th bit, if bit equal to 8, then we set bit equal to 0 and index plus equal to 1. If else, we just keep incrementing the bit. I think it should work. Except for this fucking statement. Everything should work. Maybe we could just try. Let's try how to allocate init a struct in stack in C. I really like this multi-window. There's two tabs, but we can have it in the same tab. It's good. Okay, I know this initialization. Okay, yes, we can do it. All we have to do is that we just put dot x, and I think we have done the same thing. And we don't need a semicolon here. Other than that, it's good. We just put byte index. Oh, okay, maybe the thing is we can't simply d2 and we have to initialize it somewhere. I equaled, there's no I, so it's fine. I think we can initialize it here and and return I in case we want to. If not, we just keep going. Okay, I think we have done everything. We still have to actually do the mapping, that is to virtual to physical memory, but let's see if the initial code is working. Host kernel simple MMU, and then we could go into core and we can put gcvs clang -2 test.c and test. Oh fuck me, it's clang. Oh, it's hyphen. Oh. Okay. Now we have a lot of fucking errors to get through. Okay, I didn't type def this. That's why we have that error. Type def. Allocate mem. Okay. What else? What the fucking else? Why do I need to give it as a struct? Did I not type def it? Why? I don't know. Fuck. Even if we type def it, do we have to give it as a struct? Then what the fucking point of making it as a type def? Maybe it's only for local variables. It will be useful because here we don't, I guess we don't have to give struct. Why is the total number of errors increasing? See, we should not allocate it like that. I mean, the whole point of putting type def is that we don't have to give this duct. Well, it's a warning, so let's just incomplete definition of type struct. I think we don't need this. Okay, let's just go from the bottom. What the fuck? And we have allocate. Okay, now we have used type def, we don't have to again put it as struct. Probably this is why the error came back. Maybe. And yes, we have to pass an address because they are all pointers. And what else? Passing uint star, assigning to uint star from uint star. I don't care. Just live with it. Okay, now we have some simple mistakes. Why do we have a return type for non-void function? What? Right. What? Okay, this one looks even better. Non-void function return type was 51. What is 51? Oh, it's a bit index, and we are returning bit index here, and we are hoping that it will always return something here and we'll never reach this point. Okay, then we can return null. Return 0. Then it will say you have written something else. Okay, we'll just return. I think we can do some crazy stuff and put void star it. First of all, void star it, and then make it bit index. It should work. It's a random pointer. We are casting it to. It won't work. Maybe because we are sending a value, not a pointer. Fuck. I guess we have to initialize something here and send it. What do we do? Bit index or equal to dot index equal to index dot bit equal to bit and return or. Actually, we are not supposed to leave the last. I'll just return 0. What? Do we have a value that is missing? $67. What is 67? Oh, okay. If we set something, let's just put bool valids and where is it? Where the fuck is it? Oh, it's here. Valid equal to true. Valid equal to false. Now we can actually check it here. If val dot valid not valid, only if it is valid we do whatever we have to do. Okay, if it's valid, we do it, we keep doing it somewhere. And we return set bitmap will always return true. Then what's the point? We could just okay, we'll do some hack. That is uint 64 t equal to 0, t plus equal to 1. We can use t equal to size, then true, else false. Because for every iteration, if we have found a valid bit index, then we can just keep incrementing it. If then finally the value must be equal to the size. Okay, I think it should work. Oh crap. Okay, finally it's working. Oh my fucking god. There was a lot. Finally, what we have done, we have a buffer. We are trying to allocate some bytes, so we need to first convert those bytes into pages. That's what we do in allocate mem. We check if it's less than. If it's less than, we only need one page. If it's greater than, then we need to properly figure out how many pages we need, and then we can set the bitmap. Bitmap is just going to find free pages and keep setting them as true and nothing much. And finally, the actual finding a free bit, it's a simple iteration, a simple arithmetic operation. No, it's bit based management. We just push the bit and we check the value if it's and we return it. Yep, I think it's good. How long I've been streaming? It's been 1 hour 40 minutes. I think it's a good number, and I think we have did well. We can continue this later tonight. Today evening I can stream maybe around 4 or 5. I have a phone to watch, so probably, yeah, let's see. But I guess we already have a working version. I think it should work just fine. And now what is left to do is like let's just write to do here. To do is as soon as just after we set a bit to use, we also have to map the virtual memory to the physical memory. So it's like VA to PA mapping. This is what we need to do. Yeah, we'll continue that in the second stream. Thank you guys. I'll see you next stream. Bye bye.